All right, thank you, Maarten, for having me. I will show you everything about the serverless one-stop shop we did for Qdance. So let's just get started because I have a lot to tell and there's only 20 minutes, so I'll dive in right away. So introduction, I'm Robert, I'm a technical director at MediaMonks, and basically we do everything digital for the largest and biggest brands in the world. And this is Qdance. Qdance is well known for organizing festivals and parties for the harder styles of dance music. They are part of the ID&T group, which is also known for events like Sensation and Thunderdome. So basically, Qdance came to us with the ask for a one-stop shop. That's how we eventually decided to call it, because Qdance fans are very loyal fans, and basically they are very excited to buy tickets to the events as soon as you can do that. And also they like to buy merchandise and to go to the camping grounds and go to hotels nearby. So that was really important for Qdance to change the system where they had to go to a lot of URLs to do all those things. The idea was to have one shop where users can buy everything in one go in a single purchase. So that was the goal of the one-stop shop. And at this moment, you can buy entrance tickets, you can buy accommodation, so that could be hotels or camping ground access, bus travel from and to events, merchandise, parking, lockers, and also you can insure your entire purchase, like your entire visit to the festival. So for us, the main challenge is that we had to deal with different vendors, and that means that every vendor, of course, has its own stock. So there's a limited amount of stock for everything. Most importantly, that would be the tickets to the event itself. And because there could be like 30,000 people waiting in a queue to buy the actual tickets, it could be that, of course, eventually it will sell out. So it was very important that we would manage all the stock ourselves in real time and not be calling our vendors constantly to know how much stock there still is. Also, it needs to be a single payment for the user. And our client, who was also very tech savvy, he asked us like, okay, I don't want to have any running EC2 instances, just do it serverless. And that was a very fun challenge, of course, for us to do. So to go straight into the technical details on how we did this, basically we have several components here. We have on the on the left top side, we have the front end, which I will leave out of this conversation of this talk, as we did not build the front end. It is a Vue.js app, statically generated, hosted on an S3 bucket. So that on its own already makes it serverless as well. That front end is communicating to our API, and our API is communicating to a database and file storage. We have on the left bottom side in purple, we have a few background processes, and we have an admin tool. And of course, the important bit is here the order handler, which basically reads from file storage and communicates to all the vendors. So I will dive now into more detail on every of these components. Of course, we're running everything on AWS, otherwise doing this talk on this event wouldn't make much sense, I guess. So the API basically does everything related to products and carts and orders. So this is the place where someone creates their cart, adds products to their cart, and eventually turns it into an order. We also have a lot of business rules here because depending on the time of the when the sale is live, it might be required to have an accommodation in your cart. Otherwise, you're not allowed to continue. Also, there's rules on how many premium tickets you can buy in a single purchase, or if there's maybe a limit on how much you can buy with one account. So that could be limited to once during a peak sale moment to give all the fans equal chance to buy tickets. So the API is running on AWS Lambda behind API Gateway, which is again behind CloudFront. Lambda communicates itself with Elasticache Redis, which we use as a persistent data store. So it's not just, we're not using it as cache, we're using it as our primary database. And whenever an order is completed, we will write the order JSON file to an S3 bucket. And that's basically end of story then for the API. because then it will go to the order handler. And basically, the order handler takes care of informing all the vendors. And that could be like one vendor because you bought a ticket, or it could be two vendors because you also bought merchandise, or it could be three and you also bought a bus travel ticket, for instance. So that amount is variable, basically. And also it will send emails. So right after you have done your order, it will send you a confirmation email saying like, thank you for your order. We're going to process everything. And after it's done informing all the vendors, it will take all the information from the vendors. So it will take all the order IDs from the vendors. It will put it in a single confirmation email again, and telling you as user like, okay, you got a ticket. This is your order number at the ticket vendor, and you bought 2 T-shirts. So this is your order number at the merchandise vendor. So that's what the order handler does. How it works, it's using under the hood, it's using step functions, which is a serverless state machine, and that's really, really exciting stuff. How we trigger it is pretty easy. Basically, as I mentioned, we are storing something, storing an S3 JSON file, a JSON file on an S3 bucket. When that happens, it triggers a Lambda, and then that executes the order handler. Unfortunately, there's no way to directly trigger a step function from S3 yet, so that's why we're using the Lambda to do that with. Then the order handler itself, it has a couple of steps. So of course, right away, it sends the confirmation email. It uses a simple email service to do that. And it will just, as I mentioned, tell the user like, thank you for your purchase. We're going to process it. Then in parallel, it will start to inform all the vendors. And basically every vendor has its own queue. And when everything is done, it will combine all the details from the vendor, send you that details email, and then move the order from unprocessed to processed. And then it's done. So the order handler itself, of course, the inform vendor part is most interesting, I would think. For this, we're using dynamic parallelism. This was added a while back in step functions, and it allows you to basically loop over, iterate over an array of things, and basically create a separate loop out of that, which is really interesting because that allowed us to send something to a queue for that specific vendor. We're using callbacks there, so we're adding a token to that queue whenever the item is processed successfully. So if the Lambda eventually informs the vendor successfully, it will ping that back to step function so it knows it can continue. And when that happens for all the vendors, it will go to the detail email step. Logs of success and error responses are logged to S3. So if something messes up, we can at least see what happened there. We also have a couple of background tasks. We want to inform users if tickets are almost selling out. So we need to have a way to communicate that to users. We also have cart cleanup. So if you put something in your cart, we are reserving that for you. So if you put a ticket in your cart, it's yours. The only thing you need to do is book it on time. So you need to pay on time. You have like 10 minutes. There's like this countdown timer where when it hits 0, your cart will be removed and you can no longer purchase, and then you lose the products in your cart. That's something you need to do in a peak sale, because otherwise people are taking too long, and you just need to sell out your tickets quickly. Also, we have some dashboard statistics, which during a sale is of course very interesting to know how fast tickets are being sold. What was the difficulty here is that in peak sale mode, so when the event actually is selling the tickets to the big audience, there's like 30,000 people waiting to buy tickets. Those intervals need to be really quick. So the cart cleanup process needs to go very smooth and quick. While outside of peak sale, you of course still need to clean up those carts, but you don't want to run it every second. You could still do that, but then of course you're paying more money. So my own requirement was to basically have a system where I could run a cron, but have an interval from seconds to hours, or maybe even days. And also I wanted to update that interval immediately. So if I was out of luck and it was running every hour and I changed it to 1 second, it shouldn't still wait for the entire hour. It should update immediately. So I started looking into options, and it turns out, well, you can use CloudWatch to trigger a Lambda, but that would only go as low as once per minute, which for me wasn't good enough. So I started looking into step functions again. And basically, you can use CloudWatch, of course, to trigger a Lambda, see if the step function is still running. If not, you could kick off a new one. But I think the magic is this. I decided to call it Dynamic Cron because I simply didn't have a better name. And what I do here is when starting the interval, the cron, you pass the interval, which could be anything from a second to a day. It will look up to see if there's an existing one that it needs to kill. If not, then it will skip that step. Then it will actually execute the logic that you want to do. So this part could be the cart cleanup or the stock update, sending it to clients, or it could be the dashboard statistics. Then it would keep a loop counter, and it will run for like 1,000 times. So if it's running still below the 1,000 times, it will wait for the amount of the interval that I passed. Then it will execute again, and eventually, if it reaches more than 1,000, it will just restart. And with restart, basically what it does, it will create a new instance of itself, and it will kill off the current instance because it was ended. And this way you can pass a new interval, it will kill the existing one and keep running continuously. So that is a really, really nice way of doing dynamic crons in a serverless way. Also, the stock updates was interesting because we wanted to have a WebSocket connection with the user. And the obvious choice, I think, would be to use API Gateway with WebSocket support. But we decided to go with something which matched our situation better. And that was using IoT Core. It supports MQTT over WebSockets, which was something was very interesting to us. And basically what we do is we do the same as you can do with S3. You can create a pre-signed URL. So the client can ask for a pre-signed URL. We sign it in the Lambda, and then the front end can listen to updates, like it can connect to the MQTT server from Amazon, and whenever that cron is running, it will trigger the Lambda. It will pull the statistics no, too fast. It will pull the statistics from Redis and publish it over IoT Core to the clients. So that is a very easy and serverless way to have bidirectional communication, and also it's quite cheap to use. Basically, the flexibility of the architecture was shown later because we didn't have any way of monitoring at that time when we first launched, and it turned out it was very easy to add this because, as I mentioned, whenever a order was written to S3, the Lambda kicks off and it will execute the order handler. And it turns out that also step functions is just broadcasting these logs to CloudWatch, and you can listen to those and trigger a Lambda when something happens with your step function. So when a new order comes in and it will kick off the step function, basically we are writing this to a DynamoDB table. So we know exactly which processes are still running. It allows us to also pull that data and put it into the dashboard to see how many processes are still running. And also, if there's an error, step functions will basically say that it's an error state. And then we can, besides of just setting it to DynamoDB, we can also send an email again, which is a very easy way of informing someone that something went wrong and they need to look at it. Also, something that came up with COVID is that, of course, unfortunately, IDNT and Qdance, they cannot give events right now, and they also need to look at alternative ways to earn money. And they can do this using like setting up live streams, paid live streams. So they can do this by setting up the one-stop shop. You could, as a user, buy access to a stream, and basically, when you want to actually watch that stream, it could be the front end checking if you actually purchased that item. And that was pretty easy because we already had the mechanism of adding stuff to DynamoDB. So we just added also storing the order data in DynamoDB, which allows us to really quickly look up if a user actually purchased a specific product. And I think the nice thing is that we basically didn't have to change anything to the existing infrastructure. It was something we could just add to the existing infrastructure and add some powerful functionality there. So, of course, there were some learnings. I think in general, validation is hard, but it's getting harder if you have 5 vendors which all have their own validation. And it happened a couple of times that a vendor changed things. And basically, it meant that someone from the company, from Qdance, they accidentally turned on requiring the state or province for a user, which was a field that we were not asking the user because it wasn't required. So suddenly, all the orders coming in which had merchandise started failing. So everyone learned from that, of course. Also at the company, at Qdance itself, like, okay, we shouldn't touch configuration without checking in on with the shopping team. Also, it could happen that the business changed stocks. So it happened, for instance, that there was an event and someone decided for merchandise, like, hey, I got an extra 100 of these t-shirts lying around. Let's bring them to the event. While we were assuming that that stock was still reserved for the one-stop shop. So as soon as someone tried to purchase that, the vendor would actually say like, oh, that's no longer in stock. But we couldn't inform the user about that anymore because they already paid and assumed that it was part of their purchase. Also, it turns out, of course, that brands have different needs. Even within the ID&T group, it can happen that Qdance uses a specific bus vendor or merchandise vendor, and one of the other brands has a different one. Then it means that either they need to switch vendor or you need to implement another vendor in the one-stop shop to support. So I think for the future, we also want to implement a wish list. So someone can basically create their entire cart before the shop is actually open for purchases. But someone can go in if they are loyal fans. They can get in first, put everything in their wish list that they like to have. And when it actually is live, they can log in and get their wish list and go to the checkout immediately. Also, the plan is that more brands within the ID&T group are going to use this, and which most likely results into adding more vendors. Also, something really nice would be to add personalization, because based on their history, we already know what kind of things are interesting for the user. So that would probably be for us the next step to dive into and see how we can make that work also in a serverless way. So I think the key takeaways are that serverless is awesome. I guess you know, otherwise you wouldn't have joined this track, I think. Also, event-driven architecture is really powerful. I think like the monitoring things and examples I've showed, I think they really showcase how easy it can be to just add something to the existing infrastructure without even touching the existing infrastructure. Step functions is amazing for complex situations. It's I think one of the most exciting new or services that exist within AWS if you are looking at serverless specifically. And also it's very okay to use different types of databases. We're using Redis as a persistent data store for the API. We're using DynamoDB for storing our order data. And also all the information from S3 is eventually pushed to Redshift for analytics. So don't be afraid to use different databases for what they're good at. It's extremely important to actually do that because it just removes a lot of complexity for using the right tool. All right, thank you for sticking in with me rambling on about this project. I hope it was interesting. I hope you learned something. And if you have any questions, I'm very happy to answer them.
Thank you, Robert. That was very, very, very informative. I always wondered how that worked in the back. So good to see it. You probably have some tips on how to get in front of the queue for buying event tickets, or are there no such?
No, actually not. It's a very robust system. That's one of the slides I had to skip due to time constraints, but there indeed is a queue that is enabled in Peak Sale. And basically what it does, it's managed by the, not by us, the queue, but by the ticket provider. Basically what happens, you enter the queue, you get a number, and they let a certain amount of people in per second. And when they let you in, a token is attached to the query string. And whenever a card is created on our end, we just verify if that's actually a valid token with the payment provider, the ticket provider. And if you don't have a valid token, you will just send back to the queue, and you have to start over again.
Okay. Then we have another question from Sven Haverman. His question is, why didn't you use a regular RDMS system like RDS to store the order data?
That's a good question. That's something we did consider, but eventually we didn't need it. If the file was on S3, basically we only read the file once from S3, and then we pass it to step functions. So all the data we need to process it is part of the state machine in step functions. And once it's done, we of course merge it back to the S3 file. So then the S3 file also contains all the details. And after that, the process basically stops. So for us, for the shopping perspective, there's no need to put it in a regular database. As I mentioned in the end, all orders are eventually pushed to Redshift. So then people can do analytics with them.
Okay, thank you. Yeah, I think that was it for you for today. No further questions. Thanks a lot for joining today. We really appreciate the effort, and yeah, again, very cool to learn how this works behind the scene. Thank you very much.
All right, you're welcome. Thank you.